So now we are live. People
and then will I see people on the side?
No, this is a webinar. They will only see us at the beginning and they'll be able to ask questions. But people are starting to join. So, good afternoon, everybody, and welcome to the NFDI Physical Science Colloquium in November. This event is an initiative of the NFDI Consortia working within the physical sciences and aims to communicate through high-level speakers the need for data and data infrastructures and to promote their use by scientists. My name is Dr. Sara Espinosa, and I am the project coordinator of NFDI for CAT. And I'm honored to introduce today's speakers, Dr. Nancy Washton. So Nancy Washton studied chemistry at the University of Nevada in Las Vegas and received her PhD from Pennsylvania State University. She's now the head of the Catalysis group at the Pacific Northwest National Laboratory. Her research focuses on coupling nuclear magnetic resonance with computational chemistry to improve the understanding of catalytically active materials. So, without further ado, Nancy, the floor is yours.
Thank you very much for that lovely introduction. And so I'm going to get rolling. The first thing I'd like to let everyone know is who I am. So as Sarah pointed out, I'm a physical chemist. I specialize in solid state nuclear magnetic resonance. And this is a lovely photo of me where I'm typically working on one of my instruments on the floor. And this was during COVID. In addition to being a physical chemist, I am intensely interested in how human cognitive frameworks impact their behavior, especially within the scientific domain in how we function as a scientific cohort. And so I'm working with behavioral scientists to understand scientists' perceptions of the rapidly changing landscape for scientific data, and it is rapidly changing. In general, humans don't respond positively to rapid change. So, where am I and what am I part of? So I am at a US Department of Energy National Laboratory. There are 17 national laboratories around the United States, and I'm at PNNL. It is the orange circle at the top here. So I am actually in Eastern Washington State. It is nothing like Seattle. I'm on the other side of a giant mountain range, and it is essentially a semi-arid environment. It's not true desert, but it's semi-arid. And the only reason that we have a lot of water is because we're at the confluence of 3 rivers. It's actually quite beautiful here. If any of you are wine aficionados, this is a really nice place, and it rivals Northern California. And so to drill down, Pacific Northwest National Lab is composed of 4 scientific business units. I'll call them business units, and they're called directorates. And so I'm in the Physical and Computational Sciences Directorate, and the majority of our funding and the work is for basic research. It is all physical sciences, and I am in Catalysis, although what I do with my instrument actually spans multiple areas here. And so my talk today is in 2 separate parts. The first part is it's our data strategy for my directorate. So I was given the task of putting together a strategy for how we're going to move forward with data. And that's very broad. It includes AI/ML. And to be perfectly honest, we are close to ground zero here. And you'll see why. The second part of the talk, and I think is, in my own estimation, the most interesting, are the psychosocial aspects of what we're doing. So our vision, we would like to construct a data framework that allows a virtuous cycle between human and machine. And I think that ultimately, that's probably what all of us have our eye on, but we're far from it. And so there are many existing challenges. And I will say flat out, you all in the EU are far ahead of us in terms of working together and having resources available to actually move forward in the data sphere. And so one of the biggest challenges we have in the United States is implementing these fair data processes. And so as a background, there is something called the Office of Science, Technology, and Policy in the United States, and they set policy for scientific processes at a very high level. A couple of months ago, they came out with a memo that stated all federal agencies that receive federal funding above some amount, which is all of us, must have a clear plan within 6 months to have all of your data that is associated with publications be fair. And that includes 100% machine readable. And this will have to go live by December of 2024. We're not even close. And so for the Department of Energy, they've clearly said quality data are foundational for scientific advancement. And I think that we all know that. And so what you'll see is there is this loop of feeding in where we have to have these fair data processes. We have to have the repositories, analysis platforms, and then knowledge bases. There are small silos in the United States that have this, but they are by themselves, right? And I'm talking about physical sciences. Human health is a completely different area. And so I'm a spectroscopist, and one of the things that plagues me is that I will have a sample, typically samples that I don't make. There will be multiple types of spectroscopic investigations conducted on this sample. It could be a metal oxide framework, a zeolite. And so then there's 5 or 6 scientists sitting around a table, each of us with our niche understanding of our own spectroscopy. And we're basically holding our computers and looking at each other's data. And we're trying to understand what other patterns might be there. Not just, yes, I see that there's an octahedral aluminum, but much more than that. And we cannot do that. And what we need is machine reasoning to be able to pull out those patterns from disparate data types. In my estimation, this is one of the most critical things that needs to be done because there is information there, right? And in Catalysis, as in many of your areas, we have data sparsity. We don't do high throughput. I mean, I have homogeneous catalysis scientists, and they are laboriously synthesizing organometallic compounds. It's not even close to high throughput. And when I run a solid state experiment on my instruments, sometimes one experiment will be 48 hours, and there is no way to speed that up. So now imagine if we're trying to generate training data sets. We're just not going to be able to do it, at least in the way that we're currently moving. And so one of the key things that we looked at as a directorate is where most of the AI ML efforts are. And where we're looking to actually try to move into is these areas of data sparsity, but the data sets are rich in information. And that is Catalysis in a nutshell. And so this is what our challenges are here. And I think that this is true probably for most physical science areas across the United States, at least, is that a lot of our experiments are time and resource consuming. And in fact, in terms of the resource consuming, and that means the instrument time, the instruments are becoming so expensive both to buy and to maintain that it is becoming a struggle for us to replace our aging instruments. So we need to think about this more carefully. And we clearly lack high throughput methods. Forget about the robust. We don't have high throughput methods at all in most of our areas. We don't have intelligent data management, right? Now, this is something that clearly we know how to do. We have the technical ability to do it. There are other problems that are preventing it from happening, right? And then the data sharing. So we definitely don't commonly share data across our domains. So I think that one of the things that makes me a strong scientist is the breadth of my background. So I've worked in geosciences, I've worked in materials chemistry, I've worked in, I mean, to me, catalysis is primarily materials chemistry. It's just that the material is doing a catalytic reaction for you, right? And so I'm able to pull information and experiences from different domains. And I can tell you absolutely that this is a huge boon to the teams, right? I may have weaknesses in other places, but this is very, very helpful. And the second part of the talk, I'm going to focus on this psychosocial resistance to sharing data. And this, to me, is the biggest impediment besides limited resources. And so here's what our goal is. We want to be able to collect the right data the first time. How many times have you sat at an instrument or a colleague and they're kind of hunting and pecking, right? They're trying to figure out what is the right experiment to get the information that you need, right? Is the sample robust enough to provide the data that you need? In other words, for me, it's an issue of, is there enough of the analyte to be above the detection limit? And so if we can decrease the amount of time that we spend doing that, that'll help. And that's where integrating uncertainty quantification is going to come in. So in catalysis, we do a lot of NMR measurements in solution phase to do kinetics, right? So we will monitor reactions, we'll get rates from there. At what point in the signal to noise can we stop so that we don't continue running that experiment, say, for another 12 hours, right? So the goal is to decrease the amount of time that we're using the instruments for to obtain any given information that we need. And the other thing really is that we have to have machine learning tools that are integrated across our platforms. And right now, they are completely separate. And what you see here in the image, Data Hub is an internal repository that we have. It is relatively nascent. And so, in fact, after this talk, I'm going to a Data Hub bootcamp where they're trying to show what Data Hub can do for us in terms of moving our data to make it accessible and shareable. And then the other things primarily are about different investment mechanisms that we have at the lab to try to move ourselves forward. Another thing, data management. This is primarily infrastructure, but it is predicated on having the data in a certain form, right? We're talking about you have to have the correct kind of file structures and metadata and all of that. And so for the pipeline itself, again, we know how to do this. What we don't have is the appropriate metadata. We don't necessarily know provenance, all of these things. And so we have to be able to simplify the process so that scientists will not have what I call an administrative burden, right? I know here we have very heavy workloads. I would say it is rare for a scientist to work less than 60 hours a week. If we demand that our scientists do a lot of additional work that isn't straightforward and streamlined, there is an opportunity cost to that. So will they then work 70 hours a week, or something else won't get done? And the last thing is, and this is something really interesting that our National Institutes of Standard and Technology dealt with, it's these identifiers and individual data sets. And really, it's about provenance. So NIST has a system where the original data moves into a repository. When a researcher wants their data, the repository serves them a copy. And it maintains the integrity of the original data, and it's never modified, it's never touched. The third thing is the data sharing, right? So how do we set up a framework so that at every stage, people can share their data before it's published, right? After it's published. And in fact, to be perfectly honest, right now, I'm on multiple projects, and generally, you know how we share our data? We email it back and forth. I mean, this is ridiculous that we're doing that now. And I realize that there are some platforms that are set up, and here we have things called SharePoint sites, and they're actually pretty awful. Okay, but there is no seamless, say, web-based platform for our scientific projects that we can use, where we can go and put our data and we can see what other people are doing, and where you can do the data analysis within this platform. That's my dream, what I would like to see. And so what we're doing here is we're trying to set up some of these systems on our own, and the focus on building materials knowledge bases. So At Scale is an initiative that's focused on electron microscopy. And that's one of the areas that's actually really excelling in trying to deal with the data, and also machine learning. And we are trying to get to the point where we will have real-time feedback from AI based on machine learning that we've done, where it will then tell the instrument what to do, right? And I think some would argue that it's only 5 years out. I think it's probably a little further than that because of the complexity of the systems that we're dealing with, but that's where we're going. And it's primarily going to be focused on quantum information sciences and the materials for that, and non-equilibrium materials. And so the other thing that I'm focusing on is building these knowledge bases in 3 general areas because of the overlap that you can see on the right. It's for catalysis, it's for separations, and then overlapping both is carbon dioxide removal. And so there's a lot of emphasis now, especially on direct air capture. And so in the United States, there's a lot of funding for that. We're doing the science, but we're not able to bridge to the catalysis knowledge and the separations knowledge. So effectively, we're kind of working in this stovepiped area because we don't really know what other people have done and what the data shows. So the future, right? Where we want to go. During data generation, we need to have uncertainty quantification, and it will direct when the experiments can stop and when they need to continue, and also the types of experiments that we might need. We also need to have multimodal data automatically connected. And this is not just a sample in a sample holder that is gone from instrument A to instrument B. Multimodal also means disparate data types on the same sample, but the preparation methods could have been slightly different depending on the need of the instrument. And then, of course, most important for data sharing, especially to people outside of your project, it's really the metadata. And so I cannot tell you how many times I've had people give me samples and say, you know, I need to know what the structure of this is. Tell me everything you can. And I ask them, okay, what is it? What process did it undergo? What other data do you have that would help inform me? And in many cases, it is very, very difficult for me to get that information. So as a scientist, you might think, if we provide a characterization colleague with other data that we have, let's say about the structure, that then might give them a bias towards their own experimentation and interpreting those results. And you could be right. That is a possibility. I like to believe in my case that the data tells its story. And so I believe in discovery science. I know there's something interesting there. And I am going to let it sing its song to me. And I'll interpret that. And this is how I think about it. The materials, they tell me their secrets. I don't know what they are a priori. And so I operate from that perspective. And so when I don't have the full set of information, it makes it very, very difficult for me to sometimes translate what that material is trying to tell me. Analysis, well, we need machine learning tools and automatic visualizations. This is something that they're doing in biology that's very effective, especially within the mass spectrometry field for human health. And it is very, very powerful. A lot of times, you'll see numbers, you'll have plots, but when you can overlay things and visualize them within the context of the full data set, it is very, very different. And then clearly we need to share, right? And we have to stop working in our silos. The other thing is that at least in the United States, we progress scientifically many times as a professor. To become tenured in the United States, they want to see that you are the primary driver for your scientific output. And at this point, the scientific questions and challenges are so complex that single PIs no longer really have the ability to answer these questions on their own with their own small group. And that's something that the people that go through that basically judge tenure and promotions need to start realizing. And so this is how we're going to get where we need to be. We have to have more investments. This is actually a problem in the United States. Most of these data efforts are not directly funded. So our scientific projects have to fund these efforts, and that can be really challenging. The other thing is that we don't have a common ontology, not just for catalysis data, but for most of the physical sciences. So I will be putting together a workshop with some colleagues. At some point, we will have it next calendar year, and I would welcome anyone that wants to get involved. Please contact me. The goal is to have working groups primarily focused on catalysis to try to determine what are the things that we can actually do that's feasible, right? What do we need to focus on that is feasible for us to do, and then start moving forward and getting that done? Because right now, at least in the US, we're all working separately. For the sparse data areas like catalysis, we need people to develop few-shot learning algorithms for us. And this has been another challenge where the data scientist, sometimes they're reluctant to get involved with the domain scientist, in part because of the differences in the language that we use. And that can be really challenging. The physical scientists don't necessarily understand what the data scientists are saying and what they need and what they mean. And for the data scientist, they probably don't know a whole lot about chemistry. And so I've seen this over and over again. Automating existing analyses where we can, automating the machine learning, and hopefully having a data management system that isn't going to require much human interaction. And so, all of us know this, that the impact is enormous if we can get there. The key here is it's going to accelerate our scientific discovery, which is actually really critical, right? I mean, we have the rate of change keeps increasing. And this is one of the mechanisms that we can use to try to keep up and try to mitigate things. The other thing is, this was brought up to me, is addressing data equity. So for people in countries that don't have high GDPs and robust research budgets, one of the ways that they can then participate, because surely there's a lot of smart scientists in countries that don't have high GDPs, if the data is open and available, that then gives them an avenue. And if nothing else, they can see what we're doing, and they can then start collaborating with us, which is what I would like to see. Okay, part 2, the psychosocial aspects. So some of this I'll zip through, but basically psychosocial in this case, it is this combination of psychological factors, biological, primarily genetics, and the social and cultural environments. And so I'll go through the background, goals, methods, and results. As we get started, I would like to point out the pain of losing is psychologically twice as powerful as the pleasure of gain. So Daniel Kahneman is a behavioral economist. He won the Nobel Prize in 2002 for using loss aversion, which is a tenet in psychology, and applying it within the economics realm. And this is something that's actually really critical to think about as I go through this. So what I wanted to understand is, first, what are the technical and also then psychosocial aspects of our current scientific workflows? How do we do what we do? And what is the perceptions about changing to these potentially new workflows? How do people feel about that? And so we know what the technical aspects are. And my interest was where that overlap was between the technical and the psychosocial. And so a behavioral scientist, Caitlin Ackerman, worked with me and we developed a survey, which then fed into intense focus groups and a thematic analysis of all of the information that was given to us. And so the first thing I had to do is I thought about how am I going to categorize scientists, because this was absolutely necessary, and their data. And so the easiest one to describe is the instrumentalist. So say a spectroscopist. Typically I don't make my own samples. I receive it. I do some sample preparation. I run my experiment and I process and analyze the data. And so each of these cohorts was based on the physical scientists in my business unit. And keep in mind, this is very, very general, but we needed to bin it this way so that we could understand. The reason I did this is I wanted to see if there was a difference in perception based on the typical workflows that people went through. So do spectroscopists think about their data and interact with their data very, very differently than, say, a synthetic chemist? And the lab-based folks are, in fact, many materials chemists and catalysis scientists that are working in the lab. Let's say they're synthesizing something, they have PAR reactors, they're using GCMS. They're not spectroscopists and they're not just synthetic chemists. So they're basically in a lab with a lot of benchtop instruments. I'm not going to go through all of this. I just wanted to show you that I went through and kind of defined what was going on with the data at each of these stages for these different cohorts. And so the first thing we did is we put out a survey and we asked 9 questions just about general perceptions. Basically, one of the questions was, do you put your data in an external repository? Right? Do you use any of our internal repositories? Do you have an internal mechanism to share all of your data? And this was relatively straightforward. We used those responses to craft our questions for the focus group. Now, I do need to point out here that N is only 58, so this is a small data set, and I recognize that. This is completely qualitative in the analysis because N wasn't large enough. And so one thing that really was driven home to me is that almost no one puts their data on any repository. The one set of researchers that actually do with regular frequency are our computational scientists in computational chemistry, computational material science. And I think that in part it's because it's easy and it's part of the culture of their subdomain. Most people just think about the supplemental information section as good enough, right? But that's not raw data. That's kind of a data dump typically. So we did a thematic analysis. So what I did is I went through all of the responses from the focus groups, and these were intense interviews with at most 3 scientists, and there were 4 or 5 of us, only 2. There was a behavioral scientist and a mediator in the room. The rest of us were online. They did not know who we were because that could have injected bias. And we were taking notes, and then we corroborated our notes on the responses. And so what I did is I went through and I binned everything into favorable, neutral, and unfavorable attributes. And all of the red here, those are all unfavorable. And that dominated the perceptions of our scientists. I have to say that I'm generally kind of a pessimistic person. Even I was surprised by the intense concern and unfavorable perception of our scientists. And so the first thing I'll talk about is the favorable breakdown. And some people believed, and you can see here, and these slices as they are here, these are actually quantitative. So each of these slices represents the magnitude of responses in those areas. And so I think that most people agreed that this should be done in some fashion, right? Because it could save time and resources. And you can see the comments, it creates a community. It would be useful if we knew when people had tried something and it simply didn't work, right? How many of us have had to reproduce something that someone else did that doesn't work without ever knowing that it's already been done, because that never gets published, right? And the other insight was they thought, oh, well, we could actually do something differently based on data that we might see. It was really the null results, though, and the failures that people were mostly interested in. And so the neutral areas were primarily about the infrastructure and the processes. And so these were basically just comments of things that people thought were critically important, right? Most of it is we have to have the context. We have to have the metadata. And this came up over and over again. The other issue was it's going to be difficult for us to do this without having standards, without having agreed upon workflows and data structures and all of these things. And more importantly, people said, you know what? It's really got to be user-friendly. It's got to be easy for me to do this, or it's going to be a burden, and I probably won't do it. Now, this is where things get really interesting. So there were 7 general areas. These are listed in order of magnitude of the number of responses. First and foremost was a lack of resources. And I'll be clear what that means here. That means people are concerned that there is no money to pay for their time or to pay defined researchers to do this for, say, a group. So the researchers are very concerned that this is going to be an added part of their workload that they're going to have to just subsume and take in under their current funding paradigm, right? The second one was storage and access. It seems that a lot of scientists have a lot of trouble with moving their data, right? Is the data movement fast enough? What kind of repository is it going to? How is my data going to be backed up? And then being able to access it in a timely fashion. For example, we currently have a repository that uses tapes, and it can take hours. Sometimes it takes overnight. You put in a request for data, maybe the next day it'll be ready for you, right? Researchers they don't accept that. They don't want that. The other thing was competition and career risk. And this was one that actually really surprised me. I hadn't really thought about that, but this was across the board. It was in every researcher's except those that are very senior and very established, and they're, say, internationally known. They're not concerned about competition or career risks because they're already at the top. And so we're going to go through and I'll highlight some of the actual concerns. So the lack of resources is the time that it will take researchers to do this. And you need software, you need money, you need help. And this came up over and over. The other issue was a cost-benefit analysis. So researchers looked at this and said, is it worth my time to do this? So it's not productive, right? Gain versus effort. And this is now an extra step in things that can be considered an administrative burden. And so the key here is that we have to provide resources. And so my understanding is that for you in Germany and across the EU, that is happening. That is not really happening in the United States. And so the storage and access, long-term storage issues, who pays for it? who pays to maintain all of this data? In the United States, outside of human health, we do not really have, or there's very, very few federally funded data repositories. We are expected to sort this out somehow on our own, at least right now. And so I mentioned the tape drives and also little flash drives. I mean, people here are saying, I'm backing up my data on external hard drives, the, little passports and Western digital things, because there isn't anything else. And inferior network connections, I don't know what it's like in the EU, but here that's a huge problem. If we have a lot of data, it will take forever to transfer it. The next thing was this competition and career risk. So many of the staff, except for the very well-established, really feel like their careers are at risk if they're going to be forced to share their data, even after it's published. They feel that they will not be able to be as competitive. And one of the reasons is because everything has become metricized. So typically what scientists do now is they won't necessarily publish a full, complete story, say in JACS, right? They'll publish smaller pieces of a larger story so that it's more incremental, so that they can increase their number of publications. So when we are assessed yearly, because we are, they can say, oh, I had 6 publications this year, rather than I had 2, but they were glorious, right? And so what they're worried about is that if they have all of their raw data and all of the metadata that's associated with one of these smaller, more incremental publications, if someone gets to the data fast enough and sees that there is a continuing line of a story, then they could get scooped. And this was especially true for our early career scientists. They are very concerned about that. And they went on to say that competition has to be eliminated for them to do this. And so this went on even to inability to get follow-on funding. So they were going to be shut down scientifically by having their data be available. And this is a very, very serious concern. Now, we can say to them, we think that your concerns are unfounded. That is not going to change the way they feel or their perception. And we have to understand that as we move forward. The other thing is the desire to control their data and the risk. So if you put your data out there, and I'll use me as an example. So I am what I call a sophisticated NMR scientist. I did my PhD and it was focused on solid state NMR, right? That's what I did for 6 years. So I understand it as, reasonably well. My colleagues many times have no idea about solid state NMR, and they will ask me for the raw data. And I'll be honest, I will do anything to keep the raw data out of their hands. It's not because I've done anything untoward. I haven't manipulated the data in any way that is improper. I know that because they don't understand how to process and analyze the data, that it would be very, very easy for them to make serious mistakes. And I don't want that to happen. And I'm very fearful that it can happen because it has happened in the past. So I understand this concern about the data being used incorrectly. And this is a serious concern that we also have to take into account. In my estimation, there's probably nothing we can do about it. This is going to happen. But you have to recognize that people may be reticent because of this concern. And the other area was accuracy and trust, right? So in terms of us using other people's data, how do you know? How do you trust the researcher, right? I mean, especially when you don't understand the full context, even when there is metadata there. And then standards for data and workflow. Absolutely, we have to have standardized workflows. We have to have standardized data formats and file formats. And many of the researchers said, why would you ask us to do anything without that in place? There is no framework for us to do this. And I agree, we have to do it. And that's one of the things that I'm hoping the workshop next year can at least address for Catalysis. and the metadata and data structure. I mean, these are all things that we have to agree on as an international community. It is critical that we do this. And so the conclusions from this, the psychosocial research, the thematic studies is that we have to be aware and take into consideration that individuals and their domain and subdomain cultures are going to have a huge impact on their willingness and their engagement, right? Everybody understands we have to comply. Most people do not see the value in this. Although, there is variability amongst the perceived value, but if you're asking somebody to commit their time and resources to something that they don't view as valuable, they're probably not going to be very willing to do it, right? And this goes back to loss aversion. They're going to lose X number of hours dealing with this, and they're going to gain 0. This is how it's being looked at. And so what we have to address, the top 2 things that I'm going to work to address as we move towards adopting fair data processes is these administrative burdens. So I'm working to find funding and resources so that people will see, nope, we're not just going to dump this on you and force you to do extra work that you don't deem valuable. And the second thing is the career jeopardy. That one, I haven't come up with a good mitigation strategy. Those are deeply entrenched beliefs. And unfortunately, I think that it will be believed until the researcher experiences that it doesn't happen to them. I don't know that there is a good way that we can convince them that it's not possible or that it's unlikely, right? But we have to be sensitive to them feeling this way and understand it when they're reticent to participate in these new processes. And so going forward, I have put together a set of recommendations for our directorate in how I think we should approach this. And I'm going to put together, assuming I get resourced, a working group of a variety of scientists from different domains that will then act to propagate out the value and the fact that they are engaged and their voices are being heard in the decisions that we're making. And that's really big. I mean, when people feel like something is being done to them, it can be very stressful, as opposed to, I am part of this process and I have the agency and ability to affect the outcome. This is really, really important, that people need to feel like they have the ability to affect the outcome. And always, always keep this idea of loss aversion in your minds, because it is ever present in people's thought processes. And the last thing is that the psychosocial study was funded by internal research monies at Pacific Northwest National Lab. And I am very, very grateful that they funded it. It has absolutely been fascinating getting to the bottom of this. And with that, I will say thank you very much for your attention, and I'm more than happy to take questions and comments and have discussions.
Nancy, thank you so much for such an insightful presentation. I found it amazing. I have some questions in the chat. No, I have some questions in Q&A, and I would like to ask everybody to write your questions in the Q&A slides. The chat is not working, so please use the Q&A. The first question is from Nathan Dillman. How do you see the contributions of ontologies and machine learning in building a knowledge base?
So I think the ontologies are a critical foundation for defining the relationships between things, right? And so I will preface this by saying I know only very little about ontologies, and what I do know is primarily from the philosophy realm. But in the absence of having a clear definition for a word and what it represents, we cannot move forward, because, so I'll use the word aggregate. Aggregate brings to mind something very specific to me. My materials scientist colleagues do not have the same vision in their mind of aggregate. It means something different. So with an ontology, we can clearly define what each thing means, what its boundary conditions are, because in the absence of that, there will be many gray areas where it will not be clear the meaning of something. And so we do need to have that as a foundational framework, but really to deal with any of the data. And that's kind of unfortunate because dealing with the ontologies is actually pretty hard. And then the machine learning is going to come in that it will be a consumer of the data, right? It will generate, but it will consume data as well. And for me, machine learning is a way to diminish the brute force of running experiments and spending our time. It will, I hope, speed us to discovery so that it will be less labor and resource intensive for us. So I view this as a complete data environment. And right now, what I'm focused on is just getting the data to the point where it can live in this environment and be useful.
Thank you. I agree with you. We have a task force, a task area dealing with ontologies in NFDI for CAT, and they were also confronted with a very, very big task. And it's really interesting to see even the small differences in the languages. For example, the characterized in written in English from the US and characterized written in the English from England and stuff like that. It was very interesting to see, and we are working really hard on it. So we should really keep in touch.
Yes.
The second question is from Pedro Dolobella Portela. Nancy, could you please comment the interaction between the NMR specialists in comparing their particular views of a specific analytical process? I mean, what about the psychosocial barriers in accepting a slightly different side of nomenclature or classification?
I don't think I understand the question. So you're asking me to think about NMR spectroscopists. I got that part, but it was the last part of the question I didn't quite understand.
So let me see, maybe Pedro, would you like to ask your question yourself? So I just added him, let's see. Pedro, are you there?
Okay. Yes, now I have my microphone. Nancy, what I mean, you mentioned just before about ontology. When you're discussing with material scientists, that means from another domain, and then you discuss. But my point is exactly when you have to discuss you and two more in area specialists, and you have one specific view of how to define a given step of your process, or how to classify what is a primary data, what's a metadata. And your colleague has a slightly different view. And the third one, another one.
Yes.
There are many truths.
You're right.
But how to put them together into an ontology? I think the discussion across borders is even easier than the discussion inside your domain. That was my point.
You know what, Pedro? You are absolutely right. About 13 years ago, I was working with a panel at the National Institutes of Science and Technology, and we were a group where we were trying to come up with data standards and agreements for nuclear magnetic resonance data. I called in, I participated on these very long, very laborious discussions for 6 months. And then I gave up, really. Because there was so much petty infighting. I mean, people would argue about the most trivial things, in my estimation. How many, floating points do we need? Let's just figure out the bare bones minimum. And guess what? Now, 13 years later, there are still no data standards that have come out of that committee. So you're right. I don't know how to deal with that other than to say that we have to agree on a bare minimum and perhaps stop trying to make it perfect and make it so that it's finished. Let's just do something and get it out there and then make it better as we go, because otherwise we're frozen. By the way, this is actually what Elon Musk did for the Tesla batteries. It doesn't matter what you think about him as a human being. It was very ingenious. The reason why he has all of the superchargers across the United States, he's the only one with this network. So you can charge a Tesla to 80% in 45 minutes. Nobody else can do this, right? None of the other manufacturers. And he did it, and he got it out the door because he said, it doesn't matter if it's not okay. Get it out, and we'll keep improving it as we go. And now he's got a corner on the market. I think we could probably do the same thing.
And better.
Yes.
I don't know. The next comment is also from Pedro. It's more a comment. So should I read it? Yes.
Yeah, please.
So we need a change of paradigm. Reliable data must become scientifically valuable, not only publications.
So this is where we're trying to assign DOIs, right? These identifiers, so that if people use your data, they will cite that DOI, and then nominally the scientist that originated that data will get some credit for it. I think it's a weak argument, but it's better than nothing.
Mark Dorr responded to this comment. This is very important, but we should take into account that in certain areas like topology in math, some findings are only extremely valuable for 9 other experts in the whole world. So it should not be the absolute quantity of usefulness, but per scientist.
So Mark, perhaps we should normalize it nominally by per capita, where per capita means the number in the cohort of people that could benefit from that data. This would be a great mathematical way to deal with that.
So the next question is, I hope I'm pronouncing it right. It's from Onak Manix. Is the psychosocial study published somewhere? Is there somewhere we can get more information?
So the answer is no, it hasn't been published yet. Although we did receive, in the United States, it's called IRB. We have human subjects research approval. We just haven't finalized everything yet, but our goal is indeed to publish it. So if you're interested, send me an email. There are some studies that have been done. There are very, very few, but there are some, and I could probably send them to you.
Thank you. The next question, again from Mark Dorr, regarding funding in science. Since big findings like X-rays and antibiotics are in most cases random, should we found at least 10% randomly lottery to leave young researchers' career concerns to share data?
I think that's a great idea. I can tell you that there is probably 0 probability that the United States would do that.
Thank you. I really don't know if that would be possible even here in Europe. I don't know.
Yeah, because peer review is so important, right? We have this idea that all of us assessing somebody's ideas, that the outcomes will be better. So just as a quick aside, so the National Science Foundation is the largest funder of physical sciences research in the United States. They did a study, and what they were looking for is the proposal scores that the reviewers gave versus productivity and output. And this was only on funded proposals. And guess what? There's no correlation, none.
Amazing. There's one question. This one is anonymous. Could you comment on possible cultural factors in the psychosocial study? Would you assume that the outcome holds outside of the US, for example, in the mentioned low GDP countries?
Yeah, this is a great question. And in fact, no, I would not assume that the outcomes that I've gotten here would apply necessarily to anywhere outside the United States. And there's a couple of reasons. I think that the United States is somewhat unique in its extreme individualism. So the United States is based on this idea of this sort of rough and tumble individual that does things by themselves and, you know, goes out and conquers the world. So culturally, we're brought up in an environment where we're told to be independent and to not necessarily work in a communal way. That is not true in other countries necessarily, where people have more of a community mindset, and that has a huge impact on how people are going to feel about sharing anything. And so I'll give you an example. I grew up very, very poor in the United States. And when you're very, very poor, I think anywhere, you learn that you have to rely on people in the community for help because you have limited resources and limited abilities to do it on your own. For people that don't grow up lacking resources, that are potentially very affluent, they have the ability to basically have all of their needs met without having to have this community structure. And I think that that is a very important factor in how people perceive this entire framework. So no, I do not think that these results would apply to many other countries.
Thank you so much. I hope that answered the question because two other questions just got in. The first one is from David Linke. When we start early and simple, we have to plan for later change in our pipeline, platforms, etc.
Yep, you are absolutely correct. I understand that. And that also requires a continuous funding source for supporting and maintaining. But I would say the risk of that is lower than the risk of trying to do it all, get it finished, and then put it out, because I just don't see that as feasible given how humans interact with each other. I mean, we're going to be frozen and spinning our wheels for the next 2 decades if we don't get something out that's bare bones. I'll worry about the funding later. Let's go.
I agree 100%. One minimal valuable product. The rest
Exactly.
The rest we can make afterwards. Another question from Nathan Delman. Where do we have to sign up for the upcoming metadata debate that you mentioned? Oh, that's a very good question.
Did I say a debate?
I think you said workshop next year.
Oh, the workshop, right. So email me. We don't have a date yet. And I'm still trying to pull together people. Now, do understand, it's going to be focused on catalysis. I have to say that straight up, right? So just email me. I am more than happy to include you on the initial discussions. And I think that right now, what we might try to do is have it either just before or just after the fall ACS meeting, in part because so many people go to the ACS meeting, and then we could meet there. And we could also, it would be no difficulties to do it hybrid for people that weren't coming in from Europe.
Perfect, thank you. So that was the last written question. Do we have other questions? If you want to ask your question yourself, please raise your hand. Otherwise, I have a question. In the results of your survey, did you find that people are afraid of sharing the results due to errors in the data?
Oh, yes. Yes, that didn't come up very often, But when it came up in my focus groups, I think everybody was probably thinking it, but it only was voiced in 2 of the 8 focus groups. And I was really surprised. And this was also earlier career folks. They said, I don't want people to see that I've made a mistake. And we were asking them, would you be willing to share data that you didn't publish, right? Mm-hmm. It didn't work out for some reason. And they said, absolutely not. And of course, I was wondering why. And they said, because we make mistakes and we can't have people see that we make mistakes. And I just thought something is wrong with the scientific culture in that we are so fearful that someone will see that we're fallible and human because we're not allowed to be fallible as scientists. And I find this incredibly toxic, this kind of culture. I mean, I admit when I don't know something. I admit when I've made a mistake. And interestingly, I have been criticized for this. And it's ridiculous. I mean, so yes, there is a fear that someone will see that they're not perfect.
We have actually a task force within the NFDI that are trying to deal with this subject. That's okay to be wrong and like promote people to share the data.
Hey,
I have another.
That's actually that's something I'm really interested in. Is there any way that I could participate in that just as to see what's going on?
Of course, I will send you all the information.
Thank you.
I also have another question. We had our annual meeting last month, I think, and there was a very big discussion about the quality of data. And if we should have like a minimum of quality that should be, let me rephrase, we have once our infrastructure is up and running, if we should have like a quality measure, and if the data is under this quality, then it should not be included in there. And there was a very big discussion. The one side was that data should be stored independently of the quality. People should just be informed that it's not complete, and there were another part of people who said, no, if it's not complete, it should not be there because it would just take place.
But who defines whether something meets the quality level or not? I mean, that's something else, right?
Yes.
I mean, so each little area would have to then define what that is.
Yes, that was what we were discussing in our annual meeting, how to define that. And if we do define it, should we not allow people to store their data in there because it does not meet our quality level?
I think like
what
free
do you
speech,
think? Yes.
I think it's like free speech. You gotta let everything be there. Right. And so it's basically, the truth is, it's caveat emptor, right? User beware. You should be able to assess the relative quality of the data based on all of the metadata that's present, which is why it's imperative that there be the appropriate metadata there, right? Without it, you have no way to assess the quality of the data. But I think that we should let people assess it for themselves if we get the metadata there.
Okay. Thank you. That's really interesting. And the one last question from my part, you talk about this classification of the scientists.
Yes.
Do you think we should address the use of, we should address each of these types differently when we address fairness?
Yes, I actually do. And so I'll give you an example. If you're a synthetic organic chemist, right? You are basically in a kitchen, pouring chemicals together, cooking things. There's no data coming off of an instrument. The data are your observations that are written down on scraps of paper or in a paper notebook, right? That kind of data and that kind of workflow is completely different than anybody that's working on an instrument that gets a beautiful ASCII file that comes out at the end. They have to be dealt with completely differently.
Okay, thank you. Thank you so much for this very informative talk and your answer.
Hopefully it was interesting.
It was very interesting, at least for me. If there is no other questions, yeah, thank you so much. This event is being recorded and will be, and the video will be uploaded to YouTube in the Fairmat channel. I will let everybody know who joined us today. And yes, thank you so much.
Thank you. And any of you that, I just want to say, any of you that are on that are interested in collaborating on the workshop or literally on anything related to this, please contact me. I'm Nancy Washton. I'm the only Washton at PNNL. I'm easy to find on Google. Please do not hesitate. And thank you so much for giving me this platform. I really enjoyed this.
It was amazing. Thank you so much. Oh, there's one. Yes, great talk and discussion. Thank you very much. From David Linke.
Thank you.
I forgot. I wanted to say something. Oh, I don't know. It's the same. Thank you so much, Nancy, for everything. And thank you, everybody, for joining us today. I will send the information with the link for the YouTube video.
Okay. Have a good late afternoon, everybody.
And you have a good day.
Thank you. Bye-bye.